Good day, everyone. What is electrochemistry? Electrochemistry is the branch of physical chemistry concerned with the relationship between electrical potential. It is a measurable and quantitative phenomenon and identifiable chemical change with either electrical potential as an outcome of a particular chemical change or vice versa. Next is electricity. It is the flow of electrical power or charge, and it is a secondary energy source, which means that we get it from the conversion of other sources of energy like coal, natural gas, oil, nuclear power, and other natural sources, which are called primary sources. So, by using electricity, we can transfer energy in ways that allow us to do simple chores. It's best known for the flow of electrons through conductors such as copper wires. And the word electricity is sometimes used to mean electrical energy. Electrochemical cell is a device or a mechanism that can either generate electrical energy from a chemical reaction or utilize electrical energy to produce a chemical reaction. There are two types of electrochemical cell, the galvanic cell and the electrolytic cell. Galvanic cell, also called a voltaic cell, derives its energy from spontaneous redox reactions, while electrolytic cell involve non-spontaneous reactions and thus require an external electron source like a direct current battery or an AC power source. The next is commercial cell. Refers to a single anode and cathode separated by electrolyte used to produce a voltage and a current. Batteries is a source of electric power consisting of one or more electrochemical cells with external connections for powering electrical devices such as flashlights, mobile phones, and electric cars. I have a short video here so that you can fully understand how batteries work.
A battery is a device used to store energy for a later point when we need it. We use batteries to power small electrical devices such as a flashlight. The energy is stored as chemical energy, and this can be turned into electrical energy for when we need it. If we look at a simple battery and lamp circuit, to illuminate the lamp, we need lots of electrons to flow through it. The battery is going to provide the pushing force, which allows electrons to flow through the lamp. We simply need to connect the lamp across the positive and negative terminals of the battery to complete the circuit. The battery can only push the electrons for a certain amount of time though. This time depends on how much energy is stored inside the battery and how much is demanded by the load. When we talk about load in an electrical circuit, we mean any component which requires electricity to work. These could be things such as resistors, LEDs, DC motors, or even entire circuit boards. Some batteries can be recharged, and it will clearly state this on the side of the battery. But the typical household alkaline battery can't, so this is simply disposed of when it runs out of energy. These can be recycled though, so do ensure you dispose of these responsibly. A typical 1.5 volt alkaline battery looks something like this, but the colors will vary by manufacturer. When we look at a battery, we usually have a plastic wrapper fitted tightly to the outside. This will insulate the battery, but also tell us important information such as the capacity and the voltage, as well as which end is positive and negative. The positive end is known as the cathode, and it will have this extended surface which protrudes outwards. The negative end is known as the anode. These two terminals are electrically isolated from each other. Under the wrapper, we find the main casing, which is usually made from steel with a nickel plating. This holds all the internal components in place and stops them from interacting with elements of the atmosphere, such as air and water. Within the casing, we have multiple layers of different materials. These materials are specially selected because their chemical reactions create certain levels of voltage and current. The first layer is the anode, which is a mixture of manganese oxide and graphite. The graphite is added to improve the conductivity of the mixture and increases the energy density. Next, we find a layer of porous material, typically a fibrous paper which forms a barrier. The barrier prevents the anode and cathode materials from having direct contact with each other. This helps the battery last longer when it's not being used. If the barrier wasn't there, then the battery would short circuit. The microscopic holes within the material allows iron atoms to pass through it. Again, we'll look at that in detail a little later in this video. An electrolyte liquid of potassium hydroxide is then sprayed onto the separator during the manufacturing process. This will soak it and it will be absorbed into the anode material. The electrolyte used is an alkaline, which is why we refer to this type of battery as an alkaline battery. On the other side of the barrier, we have an anode, which is a paste made from zinc powder as well as a gelling agent. The gelling agent just keeps the zinc suspended so it doesn't accumulate in one spot. The zinc is in a powder form to increase the surface area of the material, which lowers the internal resistance and thus improves electron transfer. The steel capsule is sealed with a nylon plastic cap. A brass pin is then inserted into the zinc with a steel cap placed over this. This gives us the negative terminal. Notice that the positive and the negative terminals are separated by the plastic cap. This ensures they are electrically isolated from each other. Otherwise, electrons could flow through the casing to reach the positive terminal and short circuit the battery.
So the video shows what's inside the battery and how it works, right? So now I want to discuss about the commercial battery versus the consumer battery. Commercial batteries or industrial batteries is used to imply that the battery is designed to withstand heavy use and more vibration and possible temperature extremes. While consumer battery, also called as regular batteries, are generally used to power smaller portable like laptops, cell phones, power tools, remote controls, video game systems, and all other devices that require energy without a cord. So at the left side, that's the example of a consumer battery, and the right side example of a commercial battery. Two types of battery: the primary cells and secondary cells. Primary cells are those which redox reactions occurs only once and the cells becomes dead after some time and cannot be used again. They are unrechargeable. So, it is designed to be used once and discarded after. While secondary cells are one of the most common batteries used in automobile, often called rechargeable batteries, or we called it bateria. And it is a battery is one that can be electrically recharged after use to the original pre-discharge condition by passing current through the circuit in the opposite direction to the current during discharge. And of course, the fuel cells are the devices which convert the energy produced during the combustion of the fuels directly into electrical energy or the electricity. And a fuel cell uses the chemical energy of hydrogen or other fuels to cleanly and efficiently produce electricity. If the hydrogen is the fuel, the only products are electricity, water, and the heat. Move on to the next topic, which is corrosion. What is corrosion, class? Corrosion, it is an electrochemical method by which materials are deteriorated. And it is a formation of compounds on the surface of a metal when it's exposed to air, water, or electrolytes. There are two types of corrosion: dry corrosion and wet corrosion. Dry corrosion occurs when the metals are exposed to gaseous environment, while wet corrosion occurs in the presence of conducting medium, and it is a rapid process compared to the dry corrosion. Slow oxidation of iron in the presence of oxygen and moisture, called rusting. If you ever wonder why nail rust, it's because rusting happens when a metal is exposed to oxygen. The molecules of iron on the surface of the nail exchange atoms with the oxygen in the air and produce a new substance. So the reddish-brown ferrous oxide, aka rust. Is there any similarities between the browning of a nails and the browning of an apple? Okay, let's see. The apple contains iron atoms. When it is cut and exposed to the atmosphere, it reacts with the oxygen and moisture present in the atmosphere, so that the iron atoms, they get oxidized and develop a brown color. So both of the iron particles, and in this case even an apple, are getting rusted. It proves that both oxygen and moisture are important for corrosion or rusting to take place. Now, we have to prevent corrosion from taking place. Why do we have to prevent corrosion? So we all know that a lot of articles made up of irons. When an iron used in a lot of substances and article these days, when it gets rusted, it degrades the properties of the iron articles. So in order to prevent iron from being rusted, we have to carry out some method to prevent corrosion. These are the barrier method and the sacrificial method. Means we have to prevent the surface of iron to come in contact to oxygen and moisture in order to prevent corrosion to take place. Painting is a great low-cost way to protect against rust. The paint forms a protective barrier between the metal and the corrosive elements. Picture in the middle is an example of oil grease. Oil not only lubricates metal parts and allows them to move with less friction, but oil also forms a protective barrier against rust. So the principle here is pretty simple. With a coating of the oil, moisture can react with the iron and the metal and cause rust. Third picture is an example of electroplating to prevent corrosion. Electroplating entails the electrodeposition of a metal onto the surface of a steel or iron product. This metal coating acts as a sacrificial barrier that can slow and even prevent corrosion from forming on the underlying material, which is referred to as the substrate. The next process is galvanization or galvanizing. It is a process of applying a protective zinc coating to steel or iron to prevent rusting. The most common method is hot dip galvanizing. The picture is an example of galvanizing in which the parts are submerged in a bath of molten hot zinc. That's all. Thank you. I hope you learned something from my discussion. Bye.